So for us to start a quiz, all right. These are the information for the quiz. The quiz will be starting by 10:15 a.m. this morning. This 10:08. So I think we have like 7 more minutes before the quiz starts. So the quiz starts by 10:15 and ends by 10:45. The quiz is just 15 questions. Yeah, 15 questions. And then the link to join is the link on the website, but yeah, the link there and then the code of joining is also being stated there. So these are the information needed by 10:15. So before then, if you like to relax your mind or find a pen, yeah, probably you want to jot some stuff down before then or during the quiz time. So you have the time, you have the opportunity right now. So let's just wait for others to join us till then. This 10 on already. Yeah, we have 6 minutes left. So enjoy the quiz as it starts in a few minutes time. So 5 minutes left. All right, so while we wait, if you have any question regarding the past topics, probably your question might be in the quiz. So if you have any question, just bring it on. I'll be here to answer it before the quiz starts in 2 minutes. Any question from anybody? Yeah, thank you for that. So the quiz starts now. Yep. Okay, yeah, if you're just joining the call right now. So here is the information you need for the quiz. So the time stipulated for it is 10:15 to 10:45. Then the link is joinmyquiz.com, and then the code is the code you can find there, that 3241. So yeah, you're welcome, Priscilla. Priscilla. All right, so I've changed some information regarding the test environment. So the new code for joining for those of us that have not attended is the code you can see right there, and then the time has been rescheduled from 10:45 to 11. So Faith, are you still on the call? Yeah, I'm not sure if she's here.
Yes, I'm still on the call.
All right, all right. So I hope you can see the code now. So try to rejoin. All right. So congratulations to everyone who have done the quiz. Yeah, congratulations to everyone. So we'll move on straight down to the main talk of today. So I'm coming. Okay, so we are done with the quiz section, and we are moving on to the topic of today. So, based on our past 2 weeks of biweekly session, we've dealt with the classification models and then the clustering model. So, for the classification model, we have the logistic, we have the what else we have there? Logistic, we have the decision tree, the random forest, the support vector machine. Also, we have the k nearest neighbor, but it wasn't included in our curriculum. So, if you want to read outside of the box. So we also have the KNS neighbor. And, the other we have others classification model, but the basic one needed for ML basics, just like we stated in our curriculum, is what we'll be treating for now. So now, first, starting with the logistic regression. What is the logistic regression? For our week 3 and 4, yeah, we did regression. That's linear regression and the way it should be plotted. If anyone can hear me, please signify by sending an emoji so I know I'm not speaking to myself. Can anyone hear me? All right, thank you very much. So today we are moving on into logistic regression. Um, boom. So logistic regression is a type of classification model that predicts on classes. Let me just say that it predicts based on classes. Classes in the sense of either a yes or a no, or a pass or a failure. So that's just different type of classes. So now we'll be performing an experiment of a student either passing or failing based on the hours of studying. So using that as an intuition, we'll be moving on straight into the intuition of the logistic regression. How does it work? How does it function? How do you create a model on it? So moving on that, so we have the first person, which is Alice. So Alice studied for 1 hour and then she failed. So that's a data that we're training on the logistic regression. We want to understand how the logistic regression thinks. What does it look for in the data? How does it predict the value? So just based on the intuition alone for the logistic regression. So for the data point 1, which is based on Alice information. So Alice has studied for 1 hour, then she failed. Now let's check up another data. So we have Bob. Bob also studied for 2 hours, then he failed. Yeah, you can study for 2 hours for an exam, 2 hours per day for an exam, based on the exam complexity. So also we have another asset, that's Charlie. So Charlie studied for 5 hours, then Charlie passed the course. So we're already filling up this on our graph. So the graph is being plotted by the rate of passing and then the hours studied. Normally, we believe that the higher the amount of hours studied, the higher the chance or the higher the probability of passing the examination. Yeah. So moving on, although some people are genius, yeah. So David also studied for 4 hours and then he also passed the course. We are still filling up our data points on his scatter plots. So also we have Eve, which she studied for 1.5 hours and she also failed the course. And lastly, we have Frank. Frank studied for 4.5 hours. That's 4.5 hours. 4 hours, 30 minutes. And he also what passed the course. So if we are to bring up these data points into a regression model, for a regression model, it finds the line of best fit, right? So trying to plot in a regression line into this scatter plots, we'll be having something like this. So this line is not a best fit because it predicts values that are below 0 or values that are above 1 if the hours of studying is above 4 point. I think the lowest we have there is 3 or 4.5. Yeah. So if the values are getting higher than 3.5, which is supposed to predict for pass, it will be having a value higher than 1. And the value higher than 1, like 2 and 3 and 4 and 5, are not based on our classes. We only classified our data to be 0 and 1. 0 for failure, 1 for pass. So if you're getting a value of 2, because you're using a regression model, your output, your inference won't be flexible in making. That is, you won't have an inference to make based on the output of your model. So we have to find a way of fitting these data sets into a model that can predict for us just based on what's zeros and one. So that's what bring about the sigmoid function. Don't look at this too that it creates a line of best fits that looks like S. So let me just remove this formula so it won't be yeah, so something like this. So this right now is that for any value that is in between 0 and the cut line here, this cut line here should be predicted as what? 0. Then any line, like any value or any data set that is between this cut line here, then down is should be predicted as what? Pass. So the higher the rate of you studying, the higher the probability of you passing the examination. So that's one of it. So we'll move on into the next one. So yeah, this is a very good example of one. So now we are trying to like predict for Grace, which she studied for 3.5 hours. So for you to be able to predict for Grace, then you plot the hours in which Grace studied on the time scale. So this is it here now, 3.5. So Grace studied for 3.5 and then should be having an 80% probability of passing the examination. I hope I'm not complexing, making this complex. So if you're on the same page, all right, thank you very much. So let's just move on. So Grace has an 80% of passing the examination. So that's just part of it. Also, this sigmoid function can also be plotted as there's something called the maximum likelihood function. For statistician, if you have like probably a background of statistics, something called maximum likelihood function, and then we have the likelihood function. So this sigmoid function, being able to properly predict the value of Grace, you understand now, is called a maximum likelihood function. You can also have something like this, where the curve is being shifted to a point, probably because of an outlier or something. Then during the training, it wasn't able to understand the pattern of the data very well. Then it was assuming that the data set is to be like breaking from this point. So that assumption is what we call an error. It is a bad fit. It is not fitting properly into the data sets. And what causes that is what it is a likelihood score, but a low likelihood score. So imagine someone like is it if yeah if that scored I think so something that studied for 2 hours, and then this model is trying to predict that if is it Alex, I don't, does that guy that studied for 2 hours is also passing the examination. Meanwhile, that is a wrong assumption. So this, an example of this is what a bad fit of a likelihood score. So some people train their model. Sorry, I'm coming. So some people train their model, they have this type of a distribution, and then they just take it in and then start using it for prediction, which is very, very bad. So that's just an intuition for the logistic regression. So this is a good fit. You understand now? So this is a good fit. It calculates the probability of each data point in passing the examination based on their hours of study. So if you have any question, yeah, so I just wrote a summary. So linear line doesn't fit into a yes or no data very well. So we have to use the sigmoid function, which can be gotten from the logistic regression model. So the logistic regression model is based on classification model that predicts between a 0 or 1 or different classes. And also the fit, we find the best curve using the maximum likelihood function. So there's a way they calculate the maximum likelihood function. I don't want to jinx also statistics calculation right now. So let's just understand the intuition behind the logistic regression. So if you have any question, we have just 2 minutes for that. And if there is no question, go just give a thumbs up. Then we'll move on into the next model for today. Any question from anyone? All right. So no question. Comment. All right. Thank you. Okay, so without wasting much of our time, let's move on into the next model. So the decision tree. Yeah, decision tree is like the names itself is already explaining what the model does. So it's decide based on a tree distribution. So how do we split data to make decision? Yes, you have a data set. Then how do you make a decision based on the data set you have? How do you split it into making the decision? So let's visualize the splitting process step by step. So the first now, we have this data set now. a scattered diagram of a red dot and a blue dot. They are all mixed together. But now we have to like train it on a regression model. So this is having a variable y, which is the dependent variable, and the variable x, an independent variable. Normally, I'm supposed to use a higher dimension data set, probably a 3-dimension, but that will be going into some higher resolution of representing that data set. So just for simple and easy assimilation, we'll be using just a two yeah, that's a single variable. That's a variable y and a variable x. So we can imagine that the variable y should be coming the growth of plants, and then the variable x should be the amount of watering the plant is having. So from there, I think that's an example we can build on. So the higher the growth of a plant, the higher the amount of flowering, like the amount of watering. So moving on. So we've plotted the scatter down. So how does decision tree works on this data set? So first, what it does is that it makes a split from data sets, like making a split so that you have a particular that is trying to like segment the blue dot on the side and then the red dots also on a particular side. But since they are mixed, we can't get that by a single line. So we have to like bring up multiple breaks of line, which are called nodes. So we have to like get multiple node on the scatter diagram for us to be able to decide where a data point falls. So for that now, we are starting with x is equals to 60. So imagine that the amount of water we implemented on our farm or that we sprayed on our farm is 60 gallons. So when x is equals to 60, then we are breaking the line from here. I hope you understand that. So moving on to the next one. So is the question is this now, is x, if a new data set is coming, the model will ask, is x less than 60? Let me show this again. The red values here are the values of x that are less than 60, while the blue value here are the values of x that are greater than 60. So if the model is trying to make a prediction, the first question is actually saying that is x less than 60? So if x, that is the new data set, is less than 60, then it's either go to the yes or the no. So if it is less than 60, then it will predict it to be red. And if it is higher than 60, it is still no. Yeah, it is also still mixed. So from there, we also have this again. So we have to break it again. I'm just trying to like show us the different type of modes that we can have for a decision tree. So now we're trying to like segment it again. So we can have the reds on the parts, the blues on the part, and then another small set of the red values. So for this small set now, we are trying to break it with y equals to 30. So if the y variable like now is equals to 30, if it is higher than 30, that's certainty that what it will be red. And then if it is less than 30, where x is also greater than 60, then there is a certainty that what it will be a blue dot. I hope I'm not mixing it up for you guys. If you understand it, please just give a thumbs up before I move on. Hello. All right, so I hope you all understand. So moving on from that angle, we already have the splits from data set. So yeah, someone saying something. Okay, thank you for that. So I should just come again. So what I said here is this now. We are trying to split the scatter diagram into different leaves. They are called leaves. So trying to split it, the first condition we gave it is that if x, that is the independent variable, the x, the horizontal line down here, if it is greater than 60, I'm coming and just back it up there. If it is greater than 60, that the line should just be on 60. So if the imputed predicted the value you're trying to predict is greater than 60, there's high likelihood that there's a highly probability that the value will fall on the blue segment, right? But for the values that are lesser than 60, we still have the red and the blues mixed together. So we can't just assume that any value falling below 60 for the variable x should be predicted as what blue or red, although the red are more likely to happen below 60 than the blue, because there are just two blues here. There are two blue dots here. So that's just the first split that we made. And then I explained the diagram of how it works. So if the new value, probably the new value is like 45, So the model we ask is S less than 60. 45 is less than 60, right? So the model predicts what? Yes. So the value is highly to be read. You understand now? Or if it is higher than 60, the value is what? No, because there's still some other points in that scatter diagram. So it can't predict it to be yes or no. So there you have to create another node again for you to be able to predict where the value can belong to. So moving on to the next one. So we now created another and that was another leaf. Let me say that we created another leaf where the reds are now on the parts, the blue are on the parts, and then the reds also are on a separate part. So with this type of a decision tree diagram, it is easy for you to like even guess what the value will belong to. So if you say that 45 that we said initially now, we already said this place here is where X belongs to 60, while the Y belongs to 30. So we are trying to produce for value 45. That is, if we water the farmland with 45 gallons of water, how will like what will the color of our plant be? Is it going to be red or blue? So using that intuition, we cannot say 45. So since 45 is lesser than 60, there's high likelihood that our plants fall on to be on a red color, right? You understand that now? Hello? All right. So yeah. So moving on with that now, we have coming. Why is this thing not moving? Yeah, so we now create another leaf. So the first one was based on X lesser than 60. So we have been able to predict that if it is greater than 60, if it is lesser than 60, then surely it will be what's red. But if it is higher than 60, we also have to make another decision. And then the decision for it being higher than 60 will be on Y variable. So the Y variable will also have its own condition that if it is also lesser than 60, should it be red or blue? Yeah, so moving on. So the Y function also predicts that if it is yes, like if it is lesser than 30, then it should be predicted as what? Red. But if it is higher than 30, it should be predicted as blue. So this is just a very simple and short explanation of the decision tree. So this is how it works. It goes on a yes or no variable. So if you're having thousands of data sets, this is what happens behind the scene. This is what I'm trying to build. You just call the scikit-learn model, they call it decision tree, blah, blah, blah. This is what is happening there. So this is just based on the intuition. If time permits, my battery is low right now, this is 23%. And then we're still going through, I think, 4 more models. So let's just go on step by step. If you understand the intuition and then you go through the resource we've sent earlier, then it should be easy for you to understand all about these classification models and clustering model. So we are still currently on the classification model. So now we'll be moving on into the summary. So now the summary is that scatter plot, what is scatter plot? A map of our data that is on the X and Y scale axis. So also we have the boundaries. The boundaries are what make us be able to predict where the value belongs to. So the lines we draw to separate each groups. So the decision tree, the flow chart that asks what's the decision tree. So the decision tree is a flow chart that asks the question, is X lesser than 60 to find the answer of where the input value belongs to. I hope you understand that. So moving on to the next model, we have the random forest. Yeah. So random forest was a forest doing in machine learning. That was the first question asked myself when I started this random forest. So I was curious about knowing what's happening behind the scenes. So moving beyond a single decision tree. So a random forest try to build a powerful and accurate system by combining different decision trees. I hope my definition that the definition sound well. So it's a collection of trees working together. It is known as assembling method. Where you're trying to combine different type of models to function or give a single result where the results from one model depend on the other. That type of a system is called the ensemble system. So the random forest is also known as what? The ensemble model. Yeah, it's an ensemble model. So why a forest? So what is a forest? I like to identify this. So a single decision tree can be great, but it's often overfit. That's why you see most research paper, if you're the type of people that read research paper very well, because I love reading research. So most research paper comparing decision tree and random forest, there's like I can say 75% of all papers that I've seen comparing a research between the decision tree and the random forest. The random forest always outperform the decision tree. That's always happening most times, 75% of times. So a random forest fixes this by creating many diverse trees and letting them vote. Voting is much more how I say this, is much more prone to like having a higher probability of accuracy than just a single value speaking for the old data sets. So if you have a data set, then you have a lot of models trying to vote that no, this is supposed to be the result. No, this is what is supposed to be the result. So that's what happened in the decision tree. Instead of that decision tree to just be like a single model predicting a single value. For the last example we did, we said the 45 is supposed to be on a red scale, right? On the red what I say, the red cluster, let me say red cluster or red group, the red plants. So if you have a random forest, what happens behind the scene is that we train different type of that decision tree. Then they all vote. A decision tree might vote that no, this is a red. It's producing that what is a red. Another might vote that it is a gray, red or blue. So the only type of votes they can make is just between red and blue. So the higher the amount of votes for a particular color is what is bring out as an output of the model. So moving on very fast. So a simple tree, one expert, that's just one single decision tree. It is an expert, but a single expert is prone to mistakes, unlike having different type of experts. Hello, you have a question? Hello, is someone saying something? Okay, if there is no question, I think someone wrote something in the chat box. Okay, so if there's no question, I think I can move on. So I explained the decision tree as an example method for the forest, and then we have the randomness. So random decision tree focus on randomness. It doesn't just like predict based on what is happening or the past variable. It also apply randomization to its predicted values. So I already explained the voting, how it votes, combining all opinions from final, more reliable consensus. So moving on to the next one. So example is here now, we have 150 samples. Let us say from 1 to 150. So what it does is that it creates multiple unique training data sets. Multiple unique training data sets. So if you have a training data set of 1 to 50, it will create a subset from that 1 to 150. Probably I think you're able to specify that. I think number of samples equals to, I think there's a parameter for that on the random forest model. So if you're trying to build a random forest model, there's a parameter, I think number of samples. So you have to like specify the amount of samples you want for each of your trees. So if the trees are having just 50 samples, the tree 1 values will be different from the values in tree 2. The values in tree 2 will be different from the values in tree 3. So having that set of variables, having that set of what I call this now, having that set of trees, then they all make a prediction based on the samples you've inputted into them, then trying to make a vote, like a certain vote, you understand, based on those samples is more reliable than just forcing all the data sets into a single tree and then getting a sample for it. I think that's what makes decision random forest always outperforming the decision tree. If getting you confused, please call it back to me so I can just like correct that before we move on. So yeah, so this is what's actually happened. I give another example here. So when each tree decides to best split, like the other example that we gave, x less than 60, it can only choose from a random subset of a future. So if we have a feature of A to J, that's A, B, C, D to J, tree 1 might only consider A, C, F, and I based on the amount of samples you specify in your parameter. You understand now? So probably I've specified 4, number of samples should be equals to 4 in my random forest. Then the amount of values, that the amount of features that can be available for the tree 1 is possibly ACFI or any randomized amount of number that's just based on 4 from A to J. So that's just what happened in random forest. So we have that for the tree 1, the tree 2, and also the tree 3. Three. Anyhow, so this randomness ensures the trees are truly different and not dominated by one strong features. So it is already random. Then the answer you're getting from it normally okay. I'm so sorry for that. I lost my connection. So where does even fall on it? Oh my god. All right, so I think from joining again. All right. So what happened was that I lost my connection. So I'll be sharing my screen for us to follow. Where do I stop? Yeah, Emily lost. Okay. So if you have any question regarding what we've been talking about, please bring it up right now. So I just give it 2 minutes for us to assimilate what we've talked about. If you have any question, I'm available. Any question? If there's no question, give it thumbs up. Hello, is anyone still here? Okay, thank you very much. So let's move on to the models we are trying to. Okay, so I was on the random for that's my connection. So yeah, I remembered. So we said the tree one is trying to predict between the red and the blue. Probably the red is having higher probability than the blue. Then it predicts the red. Also for the tree two, it has two main options, which is the blue and the blue. Then it predicted blue. And then the 3 3 also had two options, the red and the red, and it also predicted red. So with that, we have this formation of how the prediction is being made in a random forest. So the tree one already predicted red, the tree two predicted blue, and then the tree three predicted red. So the final prediction should be what? Three, because there are two red out of just three values. That's what 2/3. 2 out of 3 votes for red. So red takes the votes. Yeah, red wins the vote. So that's just how the random forest works. So there's a summary. So the random forest is based on diversity. Each tree sees slightly different data pattern. That is, it sees small errors from each data. There are those small errors won't accumulate to what will be predicted as the final value. So robustness is very robust. Individual errors from one tree are smoothed out. If there's an error from one tree, and then other trees are trying to predict that no, this thing is supposed to be this way, and then there's just a single tree that's predicting otherwise. Probably you have trained that single tree in your decision tree. Oh my god, I think that flow is going forward. So it is very robust, and then also prone to low overfitting. It doesn't overfit, unlike the decision tree. There's high chance that you get overfitted if not well fine-tuned for the decision tree. So by averaging many complex models, so the example focus on general patterns, not noises. So moving on, we also have from the classification models, we have the SVM, the gradient boosting. I think those are the two remaining clustering models we have. These are the two classification models we have on our curriculum. But I won't be moving those into those right now, so I'll just move on into the clustering. So my laptop is 18% already. I just hope it lasts us while we go up. So for the clustering model, we have the unsupervised learning. A clustering model is an unsupervised learning. Unsupervised learning says that it doesn't need someone to like label data for it to understand what's happening in the data set before it makes prediction. So it finds the hidden group and then pattern in the data. So it's by itself find the hidden groups. So moving on. So the difference between the unsupervised and the supervised. So for the supervised model, we give the model data with existing label, just like the initial experiment we did for students studying for a particular hour, and then we are labeling it for them either passing or failing. So that's an example of a supervised learning. So most all clustering model, all classification model, don't mind me, all classification model can be classified as a supervised learning model, but not, yeah. And also all clustering model, let me say almost all clustering model, although I've not seen any that's not unsupervised. All clustering models can be classified as an unsupervised learning model. So moving on, we only give for the unsupervised model, we only give the model raw data and ask it how many groups can you find. So that looks a little bit shady if you don't have the intuition behind how the models work. Because how would I just give a model all the data sets I have in my phone and then it just spit it out? Yes, you have four data, you have four classification, you have four classes here, data sets. How does you understand that? So we'll move on into how it understand that now. So an example is this now. We have a data set that entails the income versus the spending of people. So this is a scatter diagram again. I love using scatter diagram as it gives a better institution for models. Yeah. So now let's look at a more customer data plotted by their annual income. So and their spending income. So imagine we have, it is normal that if you have a higher income, you are likely to spend more, right? So we have no predefined customer segment. So this is a rough data. Then you're just trying to bring it on into into a clustering model for you to be able to classify different segments that it has in the data set. So moving on, we have how it works, you know. So it finds, yeah, the user, like the ML engineer, you now, you have to like how do I say this? You have to specify the amount of clusters you want in a data set. If you tell the model that you needed 4 clusters, it will create 4 clusters for you. If you tell it you need 100 clusters, although it won't take, the number of clusters should not be more than the amount of data sets you have. I think that's more making sense, because how will you have just 50 data sets and then you're trying to get 100 clusters? How? So that's just behind it. So it is advisable that your number of clusters should just be, don't let me just say, don't let me go there. So just know the amount of clusters, and then that's just based on your intuition. Probably you're just trying to focus on, you know, let me say you are a business owner or you're an ML engineer for a specific business. They are trying to like classify the customers you have into segments. You know, you can just classify it as people that receive between 1K to like 100K per month. You can also like classify from 100K to let me just say 1 million, then from 1 million upward. You understand? So that's just a segment of 3, just based on the necessity of what you're trying to see in the data set. So moving on, how does the model now segment this data set? How does it segment them into each column? How does it know that no, this person is getting just one key? How does it predict the key? So let's move on into that. So what it does is that it creates something called centroid. So what is a centroid? A centroid is like let's say this now. It's like a point where it's like a center point. Let me say that it's like a center point that serves as equal distance to all data points around it. So I think that's just a little bit layman classification, like definition of what a centroid should be in a clustering model. So the centers of the potential cluster anywhere on the plot. So that's a more professional definition. So what it does is that first, it just pick up any points on the data set. So like this one now, it just selected one as it's centered to be here now. So this one now, it calculates a distance to this data point. This one is calculating distance to this data point. This one is calculating distance to this data point. Then it's that no, this place, this centroid there, name placing this centroid there is being too far. I can bring it down somewhere, right? So if the model should bring it down somewhere here, then it will be closer to this one, and almost closer to this one. But there's still a longer distance if it brings it down here. Same thing happens to this one. This one too is also going to classify, like calculate a distance from this data point, calculate from this data point, calculate from this data point, calculate from this data point. So what it does is that it's trying to find a point where it will stay to minimize its distance from each of the points. Yeah, I think that defines it. It's trying to find a point to stay, like where it will be centered to each of the data points. So we have three pillars. Let me say that, yeah. We have three pillars. Where should we place these three pillars for us to have this building to hold? You understand now? So moving on. Next now. Yeah. So this model has now been shifted. You know, for the first one here, the three was here. Yeah, same. So this three here is closer to these variables here. This two here is closer to these variables here, and then this one is also closer to the variable here. Also, it is closer to this one. You understand? It's closer to this one. So what happens there is each data point is assigned to the clusters of the nearest centroid. You understand now? So it is attached to this what do you call it again? To the cluster of the nearest centroid. The point takes the cluster's color, creating a temporary boundary for the data sets. So moving on, you see, they've all changed their location. I think I did not add one. So one is supposed to be in between these two here. So one being in between these two here is having a very minimal distance to each of these 2 points. You understand now? The list three also staying here is having a minimal points to each of these. So if we should put the one here, calculate the distance of that one to this color here, and then calculate the distance of this three to this color here, you can see that this three is closer to this than this one being here. Also, it is far from this two. So we classify it based on the centroid, and that's what the clustering model does. So now there are different type of clustering model, which we'll be looking at very soon. Coming next now. Okay, I've already, yeah, this is the k-mean clustering. Yeah, this is the k-mean clustering. I think I did not add it there. So that's how the k-mean clustering work. It's provide the centroid for each of the data points here. So step one, step two, assignments, and then step three, update and convergence. So I think, yeah, that should be the end of the slide. My laptop is already 15%. So I would like to get questions from you all. I added one. I don't know why it's not here. Okay, I'll check later. I'll just if you have any other question. So that is the end of today's session. If you have any question regarding what I've explained, please just bring it up. And I'm open to take your questions. Yeah, thank you very much. Any question from anyone? Okune, what's the issue? Do you have any question? Should I call names? You guys should just you guys also have a question now, at least, or do you all understand? It's a very easy course. You all understood it, have you? So I can just off my laptop now. All right, so you all understood this. Thank you very much for joining. So that's the end of today's lecture. And then we would like to get your feedback so we can improve on our teaching and then sessions. You are welcome, Mr. Emmanuel. So also we'll be having the results today. Yeah, before today's results, you guys will be getting the results for your test, for your quiz, I mean. So thank you all for joining and have a nice day.